We present ADNet, an attention-guided deformable convolutional neural network for high dynamic range imaging. The task of multi-frame high dynamic range imaging aims to reconstruct an HDR image from several LDR images. Qualitative proposed the first deep convolutional neural network for HDR imaging of dynamic scenes. They first aligned the LDR images with optical flow and then fused the aligned images by a CNN. We proposed the first non-flow-based approach, which performed homography alignment on LDR images before fed them into a CNN. Recently, Yan offered to handle motion by an attention module, which achieved state-of-the-art results. All prior works follow the single branch pipeline design and treat LDR images and gamma-corrected images uniformly. What's more, they usually adopt optical flow and homography as their alignment module, while use no explicit alignments. Motivated by the intuition that the images in the LDR domain help detect the noisy, unsaturated regions, while the HDR counterparts help to detect misalignments, we propose a novel dual branches pipeline for multi-frame HDR imaging of dynamic scenes. Moreover, as optical flow and homography are often prone to introducing ghost artifacts and cannot be end-to-end trained, we propose to align LDR images with an trainable deformable alignment module. Here is the illustration of our proposed dual branch network, ADNet. In the first branch, we adopt a spatial attention module to detect noisy and saturated regions. The output results is the attention features which will be used for fusing. In another branch, we adopt a pyramid, cascaded, and deformable alignment module to align the gamma-corrected images. After get the attention features and the aligned features, we concat them together and feed them to the fusion subnet. The fusion subnet consists of several densely residual dilated blocks. Here shows our experiment. The table below shows our training settings and parameters. To train a CNN model, existing methods usually first linearize the nonlinear LDR images using the camera response function and then apply gamma correction on these linearized images to produce the input images. However, as the CRF of each camera is not strictly the same, a fixed gamma value may not always be the most appropriate. In this paper, we propose a gamma disturbance strategy. Specifically, instead of maintaining a fixed gamma value all the time, we randomly apply a gamma value up to 0.24 plus minus 0.1 with the probability of 30%. By adopting this strategy, the proposed method obtains about 0.1 dB gain in terms of PSNR. The pixel values of each sample from NTIRE 2021 multi-frame HDR challenge subject to long-tailed distribution. What's more, the reconstructed HDR results are usually displayed after Tonemapped. To these reasons, we optimize our network in Tonemapped domain instead of in linear domain. During the testing stage, we adopt the testing time augmentation. Specifically, we first transform the test images 4 times with permutation and flips. Then we build 4 outputs and inverse transform correspondingly. Finally, we average these 4 results and output the final HDR image. The adoption of TTA brings 0.6 dB gain of PSNRL and 0.1 dB gain of PSNR-mu. The proposed ADNet achieves better performance than the existing state-of-the-art method at HDRNet. We also obtained the first position in NTIRE 2021 multi-frame HDR challenge, with a lead of 0.56 dB in terms of PSNR-mu and a broader difference of 0.78 in terms of PSNR-L when compared against the runner-up team. Here shows a case which suffers extreme overexposure. The results demonstrate that our method can hallucinate more accurate details over the saturated areas. This case suffers severe overexposed problems, and meanwhile, subtle motions occur over the hand. The results show that our method is free from ghosting artifacts and generates more clear details upon motion boundary. We also visualize the attention maps in the figure below. As can be seen, the attention maps can adaptively select the most appropriate regions of LDR images to fusion. To summarize, we propose ADNet, a novel dual branch pipeline for multi-frame HDR imaging of dynamic scenes. We first propose to align the dynamic LDR frames with deformable alignment module, showing significant improvements over previous opponents. The proposed method achieves better results than the state-of-the-art methods, both quantitatively and qualitatively. Our approach achieves the best results in NTIRE 2021 Multi-Frame HDR Challenge in terms of PSNRL and PSNR Mu. Thanks for watching.